Good afternoon, everyone. Thank you so much for having us here. My name's Steph Grindley, and I'm head of design at a digital agency based in the UK and United States called Made. And along with my colleague, Leo Thornton, we're here to talk to you about project workflow. In particular, we want to talk to you about how we use Patton libraries to manage workflow between the design team and Leo's team of CMS developers. I'll talk to you a little bit about the history of Patton libraries and how we decided to adopt them, and what we've learned using them. We've been using Patton libraries for the past 8 years, so we've learned quite a lot about them. I'll be handing over to Leo, who'll be talking to you about some of the workflow issues we encountered and how we built an automated process to create Silver Stripe templates from our Patton library HTML. As an agency, Made was founded in 2002. In the early days, we worked predominantly with television production companies and doing digital work for more traditional branding and marketing agencies. Agencies that hadn't taken the leap and created their own digital departments yet. It was fun, but frustrating, and we worked white label, so we didn't have ownership over our work and were unable to meaningfully build upon our portfolio. In 2008, we were asked to pitch for a website for a local theatre. We discovered during our research that there was a real gap in the market for servicing performing arts clients. As a client, they typically required high-quality, impactful design, but they also require complex technical solutions. And they would often have vast amounts of information that often needed to be rationalized and organized. Looking locally, nationally, and then internationally, we struggled to find any institutions that we felt were being represented digitally. We won that initial theatre job and decided to reposition ourselves. By 2010, our client base had shifted to almost exclusively arts and culture clients. In those early days, we were using our own bespoke CMS, but as the size of the projects we were pitching for increased, so did the requirements for the CMS. We knew that we needed to adopt an open source CMS that we could work with. We dabbled with WordPress, and in order to win an important strategic project, we had built a site with Drupal. Our CMS developers didn't really enjoy working with either of them, so as I'm sure you can already guess, we landed with Silver Stripe. At this point, the role of a front-end developer was beginning to become a tangible job title, but as a designer who really wanted to have control over my final product I was designing, I was more than happy to learn to code, and I was very often the person writing the HTML and the CSS. We'd be working directly in the Silver Stripe templates, building out pages and features and styling them as we went. It would be slow going, and it meant that the developers were often leading the production. The design team followed behind, making sure that once built, each template looked and functioned nicely. But this could cause problems. If the developer had misinterpreted a wireframe, or the design required things to work in a slightly different way, and worst of all, if there was a technical issue that impacted on the amount of time required to build out a feature, our workflow could become jammed. Often, we'd all be sat together in a group of 2 or 3 people, constantly having to unblock one another as problems arose, working so reactively to fix issues that we would frequently cause even more problems. So typically things that would happen were post-launch, the client would go into the CMS and start trying to add some content, but they'd add a HTML element that we'd managed to miss in the styling. So block quotes, H4 tags, tables might come out looking mangled, and we'd have to rush to go in and fix them and make them look good. Nothing was modular. We designed a component in a very specific way, then we realized that we needed to reuse it somewhere else, but that meant having to rebuild it or rewrite it or rethink it. And we were forever accidentally repeating patterns, particularly where someone wouldn't realize that a pattern had already been created somewhere else. We weren't even reinventing the wheel, we just had lots of different wheels that were all a little bit different. This seemed to be happening with buttons, search interfaces, popovers, sometimes to the point where you'd find 2 different types of JavaScript that were just doing essentially the same thing. Then Apple released the iPhone 3G, and we needed to start thinking about taking responsive design very seriously. After working to retroactively add responsive layouts to some of our most recent projects, we began to realize that this approach was entirely back to front. We were constantly on the back foot delivering a responsive solution that, while certainly better than nothing, still made using the site on a mobile device feel like a less refined experience than the desktop version. Moving forward, we needed a brand new, better way of thinking. We were constantly on the back foot delivering a responsive solution. In 2013, in order to make improvements in efficiency, we restructured the company. I was promoted to head of design. I now managed a small team of designers and front-end developers. Things were going through a rapid change, not just within the company, but in the way that we consume the internet, and the way that we needed to think about designing for it. Although our team was small, we had a really wide breadth of skills and experience to draw from. Designers that were able to write production standard code, and an incredibly strong front-end developer with a deep appreciation for design, accessibility, inclusivity, and process. Our goal was to make noticeable improvements to our efficiency, the quality of our work, and the speed with which we're able to create. So inspired by the writings of Ethan Marcotte, Brad Frost, Scott Gell, and a whole slew of other pioneering developers and designers, we began to plan how best to start making these improvements. First thing, we would start wireframing, designing, and building all of our websites mobile first. It made absolute sense. We'd adopted responsive design as a standard in our build since 2010, but by now we were considering mobile the dominant use case for all of our projects. We often struggled during wireframing to get clients to focus on making tough calls when deciding the importance of information on a page. To them, everything was important and everything needed to be above the fold. Wireframing mobile first meant content needed to be presented in a single column. There was no way around it. Clients would have to prioritize the importance of their content. It was something we were always having to repeatedly drill into the clients, and they almost always ignored. It was amazing to see that when this rule became enforced by a technological concern that I guess was more tangible to them, they instantly understood. Designing user interfaces and page layouts mobile first also meant that the user experience of a mobile had been carefully considered. It would become a primary consideration during the conceptual and design stages, rather than a secondary experience where problems were solved ad hoc during the development phase. Building a mobile layout outwards into a desktop design and enhancing the experience for increased visual real estate was so much easier and inspiring than trying to retroactively cram a desktop design down into a mobile device. Now we needed a way to ensure that everything that we were building could be audited, edited, and presented in both a holistic view and a compartmentalized view. So we could granularly manage the assets we had available, but also to be able to present them in the context of a real page. Which led us to the Patton library. As web design has grown as a medium, it continued to borrow from traditional graphic design in order to solve problems and create an implicitly understood graphic language. Grid systems, typography, iconography, all come from traditional graphic design. But as the management of a design system became more complex, we began to look toward things like city planning, automotive and product design, and even science to help conceptualize our thinking and begin to solve these complicated problems. So in the 1970s, architect Christopher Alexander, along with his colleagues at Berkeley Center for Environmental Structure, wrote a seminal book. Ostensibly, the book is written as a guide for architects and town planners and is titled A Pattern Language, Towns, Buildings, and Construction. The book was not just a linear guide on how to do architecture. It illustrated how specific design choices help us make better relationships. By fitting a series of these choices, the patterns together, you're able to form a room, a house, a neighborhood, and eventually an entire city. The concepts in this book were so abstract that they could easily be made applicable to complex engineering tasks, such as such, it became very influential in helping to document collective knowledge in the field of computer programming. Designers influenced by these concepts began to create their own systems and languages to help solve problems that we shared as an industry. These concepts, in turn, became hugely influential to the way that we think about design patterns and design systems. My introduction to patterns was through the book Atomic Design Methodology, thank you, by Brad Frost. Taking its inspiration from chemistry, its functions is not to serve as a one-size-fits-all process, but rather to help make a mental model, allowing us to think of user interface as both a collection of individual parts and as a cohesive whole at the same time. In this analogous comparison, atoms represent block-level HTML elements. For example, a form, text field, a button, and a label. When combined together, they form a molecule, in this example, a search input. Once a number of molecules combine together, they form an organism, a global header. From here, we're able to lose the chemistry analogy and adapt language that's more appropriate for our final output and makes much more sense to clients, bosses, and colleagues. Templates are page-level objects that place components into a layout and articulate the design's underlying content structure. Pages are specific instances of templates that illustrate what a design looks like with real representative content shown in place. Atomic design, as a buzzword, encapsulates the concepts of modular design and development, which becomes a useful shorthand for communicating the concept with stakeholders and talking with colleagues. But atomic design is not a rigid dogma. Ultimately, whatever taxonomy you choose to work with, it should just help you and your organization communicate more effectively in order to create an amazing design system. When we first saw these concepts being implemented in the wild, most notably projects such as Code for America and the MailChimp Pattern Library, we felt that this was the approach that we'd been looking for. An entire style guide that showcased every modular component of a website independent of page, then the ability to compile example pages and screens to preview and test the designs. All we needed now was a big project to come along with which to test drive our new approach. At the beginning of 2014, we kicked off a project with the Royal Albert Hall in London to facilitate a complete redesign of their marketing website and ticketing path. It was by far the largest project and most technically ambitious project that we'd worked on to this point. While we weren't sure yet if pattern libraries would be the right approach for all of our projects, we certainly felt like we had a strong case for using pattern library for Albert Hall. The project was large enough to warrant it, and we also decided to be pragmatic and create a pattern library starter that would be reusable in the future. David, the developer in charge, named it Baseplate, a name given in tribute to the base pieces used by the ubiquitous modular building bricks that we all know and love, Lego. One of the first things that we realized when separating out the front-end build from the CMS integration, it meant that the design team was able to help lead the development, as the design team worked extensively with the client during discovery and had compiled all the wireframes. It also made sense for us to start building out pages first, too. We were then able to share working examples of completed pages with the CMS team, along with annotated wireframes to work from. This led to a significant reduction in miscommunication about the end result of a certain feature. It also meant that we were able to quickly and accurately stress test the designs with different images, content, and in a multitude of different configurations. Too often, we would have to panic fix things that look great in a static design or even in a completed HTML cutter once the content and images was changed. This also afforded us the opportunity to start coding everything mobile first. The wonders of the pattern library really came into their own when several months into the project, the client announced that their leadership had now given the green light for a full rebrand. We wouldn't be receiving the signed-off guidelines and assets until less than a month before launch, and the new brand must be reflected in the new site. This immediately panicked the project managers and the client, but we were able to reassure them everything would be okay. During a critical week of CMS integration, I was able to confidently leave the studio and go and work on-site with the branding agency, applying the new logo, color palettes, typography, and graphic language. I was able to show working examples and make the case where I felt certain design decisions wouldn't work in the real world, and I could show working examples of why, and then offer alternative approaches. This sped up the process exponentially. If I remember correctly, we set aside 2 weeks to do the reskin with the new branding, but the majority of the work was completed within the first 3 days. We had merged the new CSS into the build and shipped it to the development server by the Thursday of week 1. We were confident that every page and every single component had been considered. Week 2 was used to focus on testing and making small amends based on client feedback. Not long after the RAH site went live, we were asked to pitch for a project where the client already had an enterprise-level CMS that they'd invested heavily in. They also had a very competent internal development team. However, their team had been struggling to get a redesign off the ground, abandoning previous attempts after becoming overwhelmed by the sheer complexity and amounts of radically different types of content that they had to deal with. We pitched our recent pattern library work, and we were able to win the project, delivering a full discovery phase, wireframing, concept designs, and a full and clearly annotated pattern library. Using the pattern library, we were able to prototype complex event discovery filtering just using simulated feeds from their API. The project was a great success. The development team was able to use the pattern library to construct all the different templates required with very little intervention from us, and we were brought back the following year to help extend the Patton library. Another unexpected bonus of running a Patton library came during a redesign project where we worked with the New York City Ballet. Upon completion of the Patton library, but prior to the CMS build, the client was eager to do some user testing, so we were able to facilitate this due to the speed with which we were able to create new example pages and stitch together different user journeys. Testing the patterns with real-world users was really helpful in getting... Testing the patterns with real-world users was really helpful in allowing us to make simple but really important tweaks to the user experience. Switching to using Patton libraries for large-scale projects was a game-changing choice for us, and one that brought with it so many benefits. But as we worked with Patton libraries in the long term, it also introduced some new problems. Things that we were able to live with at first, but as the projects progressed past launch, they were issues that really needed to be solved. So I'm now going to hand you over to my colleague Leo, who's going to talk to you about what those issues were and how his team worked to resolve them.
Thanks, Steph. Hi, everybody. So I'm Leo, and I'm the head of development at Made Media. I've worked with Made for about 7 years, and I work with the CMS team to bring the Patton libraries that we in Silverstripe to life. What I want to do today is tell you all the story. The story is going to be about the problems we faced when using the Patton library and Silverstripe together. It will also cover our initial idea for improving this workflow. Then the problems we ran into when we were trying to solve this, and how we overcame these problems with rapid prototyping. At the end of this story, we would like to demonstrate the workflow and system we landed on, examples of its use and why that works for us, the next steps in this process, and what that can potentially mean for all of you. Okay, so let's start off by looking at the problems we faced, because using a Patton library and Silverstripe together did present some challenges. Firstly, it's important to note that the Patton library itself exists outside of Silverstripe. It's a collection of HTML, JS, and CSS files, all served by a Node application. In effect, it's its own website that uses mock data to bring templates and CSS to life for the purpose of building out client styles and templates. So when we start working on the CMS project, the first thing our CMS devs did is recreate the Patton library templates, individually, one by one. These templates were rebuilt inside Silverstripe using a template syntax that Silverstripe could understand. But this had several problems. Firstly, it was really time-consuming. Developers had to spend a significant amount of time building out templates that have effectively already been built. Our sites were also getting bigger and bigger, and just leaving more time on the table spent building templates that, again, have already been built. We couldn't always replicate the templates inside Silverstripe exactly. Sometimes a CMS developer will need to modify the template ever so slightly, perhaps to make it fit a data model used by the CMS code. And what happens when the Patton library needs to change, especially after a CMS developer has already implemented that template into Silverstripe? Well, a CMS dev would have to come along and just do the whole thing again. Or worse, someone might implement those changes directly into the CMS, skipping the Patton library altogether, leaving it out of date. On the other hand, what if a CMS dev needs to fix a bug in Silverstripe directly? If not handled properly, we could run into the same problems. The Patton library and Silverstripe would get out of sync with one another. Oh, and did I already mention replication issues? So this put us in a tricky situation. We had a workflow, but it was problematic. We would often be fighting the workflow rather than have it work for us. This led to slow work, misunderstanding, confusion, and bugs. Lots of bugs. It's also important to understand that at Made Media, we don't just build a website for our client and call it done. We want our clients to have a site that continues to grow and change, to have additional modifications to it throughout its life cycle. But how do you continue to design new features for a site when its Patton library is constantly out of date with the live site? Reality? Not wow. So we knew we had a problem, and we knew what wouldn't help us with this problem. So what did we need? Well, we needed changes to be synced between the Patton library and Silverstripe. But realistically, we decided that the best way to do this was to identify a single source of truth for our templates. So a few of you might be thinking, well, why not just do everything inside Silverstripe? And it's for sure what I thought, and a few others as well. It's a logical idea, but as it happens, Silverstripe is fantastic at what it does. But it doesn't really fit with what our front-end team needs, especially when they need to rapidly build out a pattern library. Why? Well, the design team needs extreme flexibility with the components they are building and the example data they use with their templates. This means they need to be able to quickly and easily change the data or data structure. Silverstripe has one of the best data models I've seen in a CMS, but it's designed for use in production, not necessarily rapid prototyping. Could you imagine every time a front-end team needs to make a slight change to the data structure, they would have to change the code, log into the admin, do a build, they would then input the new data. It was a lot of hassle, especially when that data was constantly changing whilst the code was iterating. We would also need to teach the front-end team Silverstripe. While not a bad skill to have, our front-end team had a lot of front-end work on their plates. Having to do their current work in a whole new system could be problematic and time-consuming. They could rely on our CMS developers instead for data changes, but this would slow progress down or cause scheduling issues. Not great for a rapid prototyping environment. And the thing is, even if we did overcome these issues, as it currently stands, the system the front-end team uses right now is incredibly fast. All they need to do to change the data or data structure for any of their templates is edit a JSON file. Building a pattern library directly into Silverstripe would unfortunately slow down development. It's also important to know we sort of tried this. As many of you may recall earlier on from what Steph was saying, our front-end developers used to work directly in the CMS templates. And we know from experience it didn't go well. Our front-end team already had a fantastic workflow. They were always shipping on time with great results. Their work quality was fantastic, and they had the flexibility to handle last-moment changes. And also, we needed to ensure that whatever fix we did do did not break the great workflow the front-end team had. It needed to complement it. A new system, if done incorrectly, could disrupt the great system and work the front-end team provides. Okay, so we knew what problems we have, and we also know we shouldn't probably fix them with Silverstripe, so what can we do? Well, let's start by thinking up some requirements. Firstly, we know that we need to keep the templates inside Silverstripe and the pattern library in sync. It becomes problematic when they drift apart. We also want something that complements what the front-end team already have, not disrupt it. We want the front-end team to feel comfortable and work as well as they have been. We were also pretty sure that the best way to keep everything in sync and avoid confusion was to have both the Silverstripe and pattern library templates exist in one place, no replica files. Well, we knew the design team had the perfect tool for them, and so we decided why not build something off the back of that tool. As developers, we are no stranger to building assets from our source files. We do this all the time with JavaScript transpiling, for example, with Babel or TypeScript. So why can't we do the same with HTML files? We could treat the pattern library files as the source HTML files and the Silverstripe template folder as the automatically built compiled assets. And with this, the idea of the parser was born. And yes, that is really the unimaginative name we came up with. So how can we do this? Well, the idea of this course is pretty simple. Convert a HTML template from one templating language to another, save it as a read-only copy inside Silverstripe. But as we started to look deeper and start planning things out, we realized things started to get messy. To start off with, the two systems use fundamentally different templating languages. We all know how the Silverstripe template syntax works, but our pattern libraries, they all use handlebars. And some of the template usage was not so easily converted. And okay, fair enough, that's annoying. But we moved on, we carried on digging, looking further, and then we started to run into even more issues. The data layer we use in the pattern library didn't often match up with what we were using in Silverstripe, sometimes due to CMS developer preference, but in other cases deliberately so, to complement a good admin experience. We also realized that there are template tools and functions that are available to us inside Silverstripe. How can we continue to use them from template code that needs to also work outside of Silverstripe? And the more we kept digging, the more questions and issues we found. During development, the template data structure would often need to change. How do we handle that? Do we notify a CMS dev when the template data structure is changed? And add to that the initial issues we were just trying to solve. things started to look a little bleak for this project. Was it even feasible? But this brings me on to the first big lesson we can take away from this project. So let me take you on a really quick tangent, it won't take long, and discuss the folly of but sometimes. As it turns out, as developers, we tend to sometimes overthink problems. We get bogged down in the gritty details, we worry about the possible issues of any new solution we build. And rightly so. We are used to worrying about our code and, and other things, those undocumented features. And with each line we write, it is drilled into us that we should consider all of the possible ways our code could behave. This is important when writing code. But when developing a new workflow, this way of thinking can sometimes be problematic. We let problems or issues, often rare or less significant ones, prevent us from making significant progress. I mean, it's understandable. We all want our systems to be fault-proof, elegant, without any downsides. In other words, perfect. Or at least by our standards. But this style of thinking can prevent us from implementing objectively better systems. We avoid moving forward because of what might go wrong sometimes. In reality, nothing has to be perfect. Sometimes it's better just taking one step in the right direction towards a better solution. You can figure out your other issues later. And this can be really helpful. More helpful than trying to figure everything out and building nothing. You also tend to find when you have something working, the things that you thought might be a problem become less so. And instead, you find other problems that only now become clear. So trying to design a perfect system can sometimes hold you back. So we looked at the pros and cons and decided that building an imperfect system was okay for us. We were okay with some of the new issues, so long as the bigger issues we are currently facing are fixed. We believed fixing the old problems outweighed the new ones. And this approach worked out well for us. It allowed us to move forward with an imperfect system and then iterate. Inch by inch, we pushed, always in the right direction, leading us down a path and to benefits we knew we could never have. Well, we didn't know we could have. As a great man, Bob Martin, once said, a good architecture allows you to defer critical decisions. And so that's what we did. So at this point, we knew what we wanted to build, but we knew getting the time to work on this would be tricky. Our developers are often fully booked out. We would need to ensure the quality of this system was up to scratch. We can't have our site breaking due to a templating parsing error. And lastly, it was unproven technology. Using this on client projects was risky and scary. But as it happens, any agency that works with websites always overlooks the most important website that they will work on, their own. I mean, what was it? 3.0 you're using on silverstripe.org, I think it was. And we were no exception to this rule either. Our site at the time when we started this project had very little content. So it was literally a set of flat files that we would just upload to S3. And with the pandemic in full force, we decided it was time to build a new site. And with that, we were off. We had a chance to try this new approach. We had developer time booked in, we were not imposing any new systems on the client, and there wasn't really any deadline. So our initial goals were quite small. Firstly, we would only focus on converting some of the templates. We focused on module templates in particular, the building blocks used to build the bigger templates. They were frequently used across our other templates, and they changed the most. The parser would convert the Patton library handlebars syntax, the loops, the conditions, etc., into a format Silverstripe would understand. We would then store that result in a special read-only folder inside the Silverstripe template folder. The idea here being that the Silverstripe template file was generated but was never edited directly. With our initial goals being quite simple and with a lot of unknowns, we jumped right in with development without designing the system in great detail. What we ended up with, without too much planning, is exactly what you'd expect. We had a huge single file monstrosity, all within a single JS file and executed by Node. But we were all right with that because we were more worried about actually shipping it. We had a different plan in mind. We wanted to get something out quickly, something we can learn lessons from, something we could scrap, rebuild, and iterate on. We decided to look at a few choice templates. We manually converted them in a way we'd expect our parser to do, and by doing this, we had before and after examples defined. We had a spec, a way to verify our work. So let's have a look at the regex monstrosity we built. What would it do? Well, firstly, when run, it would look for the pattern library folder. This is the folder where we kept all of our templates. It would run once on each HTML file found. For each file, it would look for a special comment, seen here at the top in green. The comment would signify that this is a file that needs parsing and inform the parser where to save it. It would then run through a series of regex commands, and each command would look for a specific use of syntax, a loop, an if, or so on, and it will replace them with something Silverstripe could understand. Finally, it would save this file inside the special read-only folder inside Silverstripe and move on to the next. And that's pretty much it. And we had something. It was messy, for sure not a good foundation on a whole system or workflow, but oddly enough, it worked. It was doing its job, pumping out Silverstripe templates, and yeah, as I said, they worked. Well, until they didn't. But that in itself is exactly what we needed, because this brings me on to the next big thing we learned with this project. By having something up as quick as we did, even though it had issues, we could use it. We could start pulling it through its paces, learn from it. What did it do well? What did it do not so well? We started to see issues we could not have foreseen, even if we had planned everything in the nth detail from the beginning. When we try and think ahead how our systems might work, we rarely imagine the possible ways our system could be interacted with by our clients. By implementing the imperfect solution quickly, we were able to get this into the hands of QA testers, and early. We got to see how they use these templates in a real CMS. Through our tests, we ran into issues, but we had spent the time had we spent the time to meticulously plan out the parser, we would not have found these issues until much later on in the project, and at a time when it would be much harder to fix. With even more testing, we got to see how the parser reacted to changes in the project and as the design changes. And with that, we were able to figure out what being flexible actually meant for this workflow. Many of you may already know of the concept I'm talking about. It's quite a popular one within the developer community, and it's referred to as fail faster. Within the first few weeks of this process, we failed over, and each time we picked ourselves up and learned something new. Armed with better knowledge, we were able to focus on what really matters through this solution. So what did we learn? Well, during our many failings, we realized the mock data the front-end team used was exactly that, mock data. Once you start implementing it into a template in the CMS, its usage is open to many people. They can and will use it in very different ways. For example, even just a standard content area, one that just displayed the contents of a WYSIWYG editor, had problems. The mock data used by the front-end team would not be the same as the data that was generated with Silverstripe. We would need to address this overall workflow. We also found that the parser and the front-end team struggled when it came to Silverstripe-specific objects. How to use a Silverstripe link object inside the pattern library template, or something more complex like an image from our CDN with filters applied. We also learned a very shocking fact. Sometimes a Silverstripe template would not just receive a piece of data. It would receive an object, and some of those objects were ORM objects. This was bad news, because a loop from inside a Silverstripe template over an ORM object could have the template itself create SQL queries, a very bad practice and one that had led to significant performance issues. We were also deploying code across multiple servers, and as part of that process, we were generating HTML from source files. During a deployment, you need to be very clear when something has gone wrong. So armed with this knowledge, we got working on the problems. One area we decided to focus on was the data, specifically how we handle the data structure each template needs. At this moment, the templates are being automatically generated, but the CMS code used to get the data for these templates were all manually built. We also wanted to have something that made it impossible to pass an ORM object into a template. When you are ready to render a template, the only thing you should be giving it is data. So let's have a look at what we're working with. Each template file inside the pattern library has an accompanying JSON file. This was the example data that was used by the template. It's what we use to demonstrate how the template will look and feel to our clients. So we had a look at this file, and we started to realize we have enough information here to build out a model automatically. We have the names of each field, the overall structure, thank you, Jason, and by reading the example data and the data in each field, we could infer the data type. And so we turned to an old but proven design principle, Mvvm. I won't go into detail explaining what Mvvm here, but it is important to know how we used it in our code, and we split it into 3 different areas. Firstly, there's the model, then the view model, and the view. Here is how we used it. In this case, the model represents our Silverstripe code, specifically the part that is handmade and holds the data we wish to deploy. The view are the template files, the ones we are automatically generating by the parser. But the view model, well, this would be the glue that holds the 2 together. We wanted a PHP file that would interface between the 2, something to make it easier for our developers to interact with the template data, and also make ORM passing impossible. We decided the view model would be automatically generated by the parser. So we started working on the problem. Just like before, we started manually creating the view models inside Silverstripe, so we had a clear before and after and a clear goal in sight. And so this is what we landed on. Firstly, let's look at the screenshot of the example data the Patton library is using for a template. There's nothing too complicated here, just a few fields to show a title, some content, for the most part. And here is a file that it would generate. So we would automatically use that to generate a view model file. The abstract class you see here just handles exporting the view model to in the data layer, using things like array list, array data, where it's needed for the template. But moving down, you'll see private variables used to hold state, and a few arrays that the abstract class uses to build out the structure of that export it's passing to the templates. Going down in the file some more, we can see to make things easier for our devs, the parser creates get and set functions. We did this using the names found in the JSON mock data, useful, especially with IntelliSense. We also added array support. So again, let's have a look at the JSON file found inside the Patton library. Here, you can see an entries array with a list of objects under it. Thanks to the JSON format, the parser knows that this is an array and it acts accordingly. The parser generates set, add, clear functions, and the abstract class also ensures the data is exported in a way that is loopable by a Silverstripe template. If we look back at the JSON data we just saw, we can see that the items in the array are in fact objects with their own data structure. Does the parser need to create them as view models too? Of course it should. We automatically create child classes for each level of objects found in the schema. We do this recursively. It even added these objects to dot blocks in our generated code, just to help out our developers that bit more. All of this combined to give us better tools and understanding when it came to working with the data structure of a template. But more importantly, it helped us significantly with changes to the data model later down the line. We could literally see in our Silverstripe code what functions have changed or no longer exist. We knew we could do more, but you can't keep tweaking forever. So the time came to release our website using this version of the parser. Our prototype was not perfect. We wanted to clean it up, but it was QA tested. The site was looking fantastic, and we wanted to launch so that we could see what this would look like in production. So we shipped it. Nothing broke. Well, mostly. We had the occasional post-launch hiccup, but nothing out of the ordinary. However, fixing these post-launch issues proved that the system worked. A front-end developer would make a change to the design, and Silverstripe would just update. Sometimes we could deploy a front-end change into production with little or even no CMS dev interaction. So we did it. We're generating templates and view models. So what's next? Well, we need to be shipping it out to our clients. And with that, we needed to move our way away from the single file monstrosity. And we did that. But there was also another idea in the back of our minds. To give our customers the most flexibility, most of our CMS-controlled content is delivered by content blocks. Some of you may know it as the Elemental module. For those of you who don't know, a content block is a reusable template that you can add to your page types in any order. With our own website, we found that developers were manually creating content block code inside Silverstripe and hooking them up into the past templates and view models. We had a template for every content block already inside the Patton library. And this got us thinking, we're already automatically creating view models. Can we not do the same with content blocks? Well, with view models, it was enough to just infer the data type that was used for each field in the template. We weren't doing any strict data typing, but for content blocks, with field descriptions and different inputs for field types, building a content block automatically would mean building out an admin experience automatically. To do this, we would need to be able to exactly specify details about each data field we'd be using. We needed a framework for defining content blocks. So we worked at the problem, and this is the format we ended up with. Firstly, we split the example JSON file and that the pattern libraries use into two parts. The first part was the mock data that we've been using so far. This will continue to work the same. The front-end team would still put this in, as they have been, and it would still generate view models via the parser. The new area, however, would allow us to define the fields for the content block. And as you can see in the screenshot, we define each field with things like the data type, what tab the field will appear on, descriptions, and more. But that was not enough. Content blocks can be way more complicated than that. For example, what about lists? What if you need to create a list of objects with a specific admin structure? Well, as you can see, we came up with a way to define that too. In this example here, we can specify a has-many data type with its own schema. The structure inside the schema will then build its own view model. By default, this would be represented in the admin as a overall grid field, but we also added options for tweaking the defined names for like plural and singular and other options as well. But what if instead of defining a schema, you wanted to link to an existing Silverstripe object? Well, you could do that too. As you can see here in this example, curated concert refers to a curated concert page type, and overridable concerts actually let you specify a list of content page types. The idea here was for our generated content block fields to also connect to existing data models outside it. Okay, so that was a lot of theory, but why don't we put that all together and see what building a content block with the parser looks like. Here we have a content block for one of our clients in our pattern library folder. The block is quite simple. It just displays HTML content from a WYSIWYG editor. So let's have a look at that HTML file. So remember, the HTML file was already being built by our front-end team. All we needed to do was to add 2 lines. The Silverstripe destination comment tells the parser where to put the generated template file. This is used not just for content blocks, but any HTML that the parser transpiles. The Silverstripe content block comment tells the parser that this is a content block, and importantly, what page types this content block is allowed on. And that's it. That's all we need to do within the HTML file. So let's go back to that JSON file. Again, just like the HTML file, the front-end team was already creating this as part of the pattern library. So all we needed to do is add the extra little bit to define the content block fields. First, we define whether the content block is inline editable. This lets the parser know the content block can be edited inline. Then we add each field, specifying the name, data type, and any other relevant data, such as radio buttons, what tab they appear on, etc. And also, we have like some special cases, like show title. If that's not present, we automatically gray out the little is displayed checkbox next to the title. With that, the parser has everything it needs. It can automatically create a content block. And in fact, what I've just shown you was actually used to create a content block used today in production. With this, we have the ability to quickly and easily create content blocks directly from a pattern library, with just a few bits of data added to the already existing files. We had a foundation of a new workflow. Our front-end team could build out content block templates, create the mock data for it, ship it in the pattern library, and iterate with the client. Once that was done and the client was happy, our CMS devs would come along. They would add in those comments to the HTML file, the JSON descriptions, test the integration, and like that, we have our content block. But we still weren't finished. We can automate simple content blocks now, even some complex ones, but every now and then, custom code is going to be required. A good example of this is our video embed blocks. On this content block, our customers have the ability to input video length, title, screenshot information of any video they wish to embed. But all of this information already exists in the video the customer is trying to embed. And we could pull this automatically, but we want our CMS users to be able to curate it. And so, we can build this whole thing out using the content block system via the parser. But wouldn't it be great if we could also have a custom checkbox shown right there that when clicked, would gray out all of the fields like the description, duration, even the image content, and then just pull it directly from the video fender when you hit save. Well, we could do that in custom code, but it wouldn't work with a fancy automatically generated code from the parser. Except Silverstripe has a pretty interesting extension system. And so we built our content blocks using the parser to be extendable. When custom code for a block was required, we'd simply add the custom code to the extension. This was great because even if a content block needed custom code, most, if not all of its fields are still defined by the parser. So a front-end dev could go in and change the data structure, and unless they changed something used by the extension, it would just update. Right, Cool, finished, right? Well, kinda. What about custom types? Well, custom data types. Well, we gave the parser the ability to handle custom data types too, so that they were usable directly from the JSON file. A great example of this is this donation content block we use on one of our sites. As you can see, there are pre-selected options for amounts that the customer can pick. Using something like a grid field to specify these different values would cause problems. It wouldn't be inline editable, and for each suggestion, you'd have to go in, create a grid field item, click on it, add the amount, come back out, repeat for each one, or worse, tell the client to use a CSV. So instead, we just use a tag selector field, the one found in the blog system, for authors. With this, we just had one field. Each time we hit return, it added a new item, and we even made the export and the view model for this loopable. By incorporating this and other custom types directly into the parser, the implementation of these custom types can be defined in the content block JSON and reused across the site. There is literally a folder inside the parser where we can just add definitions for custom data types. We even use it to implement our own custom projects, such as our Cloudinary CDN implementation. Now, to use it, you just define a field as Cloudinary as a data type in the parser. And if anyone is interested with how our new Cloudinary system works, feel free to grab us later. Right, well, it had to be done now, right? Well, almost. There was just one more thing. In many places, it is required to build out dynamic features such as interactive JavaScript widgets. For this, we typically use Vue.js. But we had no real workflow for this. Our designers would build static HTML content, and our CMS developers would come in and then Vue.jsify it up, manually copying the template as they do. We knew we could do better. And so we got to work. We modified the Patton library to automatically build working Vue.js JavaScript code from the example mock data. A front-end dev would just use the same JSON model they've been using to specify the data structure of a Vue.js widget. By adding the above line to their widget template, the Patton library would automatically build out working Vue.js code, bootstrapping it with the example mock data. With this, our front-end devs could build out prototype Vue.js widgets inside the Patton library. But because these templates were using real Vue.js widget code with mock data, the template code would work and look like the real thing. The same templates would now work in production. So we could cast those templates, and then once again, keep Silverstripe and the Patton library in sync. We even built a system so that the front-end developers could build out functions that define UI interactions. The CMS devs could then use this as an interface or a guide, if you will, for what functions are needed by the template code and what UI data changes should happen when a function or action is triggered. And like that, we had a workflow for Vue.js too. Our front-end developers could completely build out a working Vue.js widget with production-ready HTML. Now CMS developers can come along once it's ready and build that out into production JavaScript widgets and plug them into the already generated templates. Okay, so at this point, we were pretty happy with the state of the parser. Oh, and by the way, we did actually rebuild it away from the single file monstrosity. With this, we had our first full version of the parser, and we launched it with our first site, and things went smoothly. And we've been using it ever since, improving it bit by bit, and it has now matured and is used for all of our site development. So what improvement did we gain with this system? Well, we now had an interaction between our Patton library and Silverstripe. There was no more duplication of templating. When changes were made to the Patton library, even after a CMS developer has implemented it, said changes would automatically sync. We implemented the Mvvm pattern. View models were now automatically being generated, helping the transition between the Silverstripe code, the template code, and it also got rid of those pesky ORM objects. We were also creating production-ready content blocks just from Patton library HTML and a bit of JSON data. The models that the content blocks were creating were fully extendable via extensions and custom data types. And as a bonus, we also got Vue.js widgets included in the overall workflow and transpiling. This ultimately led to a place where our work is now faster, has considerably less boilerplate, is less repetitive, and is more stable. We've also been able to use the parser as a consistent code style framework that has allowed us to port work easier from client to client, reducing the costs and reuse of already tested and proven code. So you're probably all wondering, well, that's nice, but what does that all mean for you? Well, let's have a look at some of the lessons learned during this process. Firstly, there were the benefits of rapid prototyping, the idea of getting something out quickly when working with unknowns. Then there was the benefits of failing faster, getting something imperfect in the hands of QA testers and learning what problems you will face as early as possible. We looked at the folly of but sometimes, how sometimes going ahead with an imperfect solution can be better than waiting until you have the perfect one. However, if all of that is not enough, there was one more bonus thing. The parser is now proven technology, and we're ready to work on the next major milestone for it, and that is moving it to open source. We want to bring this to the Silverstripe community, but also gain the shared knowledge and expertise of the Silverstripe community in return, to drive and power the changes of the parser going forward. We're still working on exactly what the new open source version will look like. We are happy for its use in production, but there are a few more tweaks we need before we're ready to release it to public. But we are committed to releasing it, and with that, we do have a sign-up form for notifications if anyone is interested. I'll put that up in a moment. But with that, and on behalf of Steph and myself, we want to say thank you. It's been really lovely being here, and we hope you all enjoyed our rant about automated pattern library integration.
Thank you very much. It was a fantastic work you've done. Took a couple of years, I guess. All right. So I'll welcome the panel up, and I'll be happy to take some questions from the audience in the meanwhile. Yes.
It looked like you had almost everything you need to also generate all the PHP code.
We do.
You do? Okay.
Oh, yeah. So literally, with that HTML and JSON, you hit go, and it will generate view models, content blocks, everything.
All right,
it literally doesn't, you don't need to write any code, and you've got a content block.
Okay, because I understood it as only the templates, like the block templates, but it's also the PHP code.
Yeah. We started with just the templates,
Yeah.
but then we realized we could extend that further,
Yes.
and not just that as well. The YAML configuration files are also modified, so we control things like the permissions of which page types content blocks are allowed on as well.
Cool.
Do we have any other questions from the audience? What do the panel think? Oh, sorry. Maxime.
I'm curious, what's your deployment pipeline looking like when you do this?
Well, actually, there's a very simple answer for that. It's called it depends. So we've actually experimented with a few different ones. Initially, we were building, so we deployed to many servers, some front-end application specific, some specifically for use just by the client in the back end, which could via an uncached layer. And what we do is we use Circle CI to deploy everything. We experimented with with deploying the actual code, building the files on the servers themselves as they're built out via CI. And that worked, but on the odd occasion, if there was a problem, it became difficult to roll that back. So what we've started doing instead is, as those initial tests, we build all of the assets to an S3 bucket, and then the deployment structure for our servers, when we spin them up for auto-scaling and stuff like that, we pull that down from S3 as part of the spin-up process.
Thomas, in the middle.
Okay, thank you. I was just wondering, what was the pattern library you were using?
It's something we built. It's effectively a Node.js application, and you feed it a couple of JS configuration files to define the structures and the sections, and then everything's built out via various HTML templates, some incredibly small, and I think Steph could probably speak a little more about that if you want.
What we tend to do is have a kind of a starter, because there's a lot of components and things in there that we know we're going to have to reuse on every project, or at least have a starting point for. We might work with the client to extend or improve certain blocks that we use, but we've got something there to begin with to start building things out. It's quite nice when working with the client to define types of content blocks that they might need, to just be able to show them the bare pattern library starter with no real, we just place all the content in, to give them some ideas about what they might need to use in their pattern library.
Yeah, and can I ask, what's the pattern library? It's HTML. I'm gathering that from. But do you have like a design process before that? And what's that program? So.
Yeah, sure. So we start out by meeting with the client, gathering all the information in a discovery process. We wireframe everything, typically using Adobe XD. Annotate those wireframes. We're working with Leo's team as well, discussing how we're going to actually implement some of these changes or ideas. And then we go into a design phase where we take the wireframes that have all been done mobile first. We'll start to extend key pages that we know are really key or might be complicated out into also desktop designs and start fleshing them out as fully designed pages. Once we've got sign-off on the concept designs, we're then able to move into the pattern library. We try to encourage the client to move into pattern library as quickly as possible. Once they're like, yeah, we're 99% happy with the general design direction, we get into the pattern library because really, you can mess around in XD or Photoshop or whatever, Figma, whatever tools you're using to keep moving things around. But the pattern library, the deliverable at the end is a HTML page, and that's what you really want to spend your design time.
Okay, cool, thanks.
Yeah, really impressive, well done. Were you able to quantify the time it takes you to build a parser, and after how many projects you're going to see the benefits in terms of the time you're saving now every time you're using it?
Oh, yes. So one of the interesting side effects that we had with this is that the project time never changed. It stayed the same, but we found that our developers were able to focus on different areas. One of the big things that changed for us was from very early on, we were able to start the discussion about what does the admin look like, not just what does the site look like. And actually, we've completely changed our workflow in how we define what the admin fields are. We no longer ask where the content's going to go, but rather what piece of information the client is supplying, the author name, etc. And we're also able to focus on other things as well and get things like our site performance, like with Lighthouse. I mean, I think we hit 99 on most of our sites now out of 100. So yeah, it really did speed up development and speed up testing. We've been able to go through QA passes much earlier in development than we could before.
Any more questions? Because I have one through the app. From our friend in New Zealand who's still up, Guy. He asks, well, of course, the first question is this going to be open sourced? And do you have a mailing list or some way we can keep up with you so we know when it's going to be open sourced?
Yep, so it is. We don't quite know when because, as I mentioned before, our developers are usually very busy building sites for our clients. And we need a new major release for this before we're ready to put it open source. But we are working on it. We are seriously looking to get some time in on it. And there is a QR code up there for a list. If you scan that, put your email in and name, we'll get back to you as soon as we've got something that's testable.
Awesome. And the panel, what do we think? Do we have any questions?
Oh, I'm blown away.
Pretty much, yeah.
Oh, wow.
But,
Very impressed.
I'm curious, like in this entire process of going through this, did you at some point consider just finding a template engine that understands your handlebars and use it to render Silverstripe content?
Yeah, we did. And it, so I think kind of lifting the veil of the curtain a bit here, it's not just handlebars. Originally when we were looking at this, it was like, oh, it's just handlebars and Silverstripes and this will be no problem, we'll get this done fine. But actually, it's like we were saying earlier on, the longer you dig, it's like, well, actually, no, you need to use like Silverstripe specific things. And if you're having one source of truth in your pattern library or somewhere else, that needs to understand how that works. And not only that, we had a lot of custom functions as well. Like we've got our own things that we use on a regular basis. Like we use Cloudinary, a image platform for CDNs, and we've got our own way of interacting with that. We actually have bypassed a lot of the file handling in Silverstripe. We actually directly interface with Cloudinary. We actually got a significant performance improvement doing that. And so the pattern library needs to know how to do that as well. So by using the pattern library itself as the base, we were able to put those customizations in, but we decided to make those customizations as extendable customizations, so we could add more in going forward. And at a stage like this, you can, if you've got your own development process, you can put your own in as well. So yeah, so we did look for others. We just didn't find any that worked for us. And also, to be honest, the design team was using the pattern library already, and they were doing great results with it. So it also, from our perspective, made sense to just continue using that tool.
But it feels like I mean, we always talk about headless and so on. Isn't this something where you could have like a GraphQL API behind it that feeds this parser that renders your pattern library?
Potentially. So one of the interesting things is the pattern library, one of the unsung benefits of the pattern library is you are also defining what's appearing in the backend structure of the admin. And that's one of the things that I worry about a little bit about headless. You are separating, you know, your front end and your back end, but ultimately you've got to ask your client those questions. You need that content. So this allowed them to glue together. But it is conceivable that instead of building templates, it just does the code that you can then use to power a GraphQL or headless environment. And I can see that being a possibility, but it's not something we're actively investigating right now.
Okay. And then how do your migrations look like if you have like content blocks that you generated out of your pattern library, and your front-end developer comes up with new fields, changes data types? How do you deal with that?
So when you say migrations, are you meaning from a site that didn't use this approach, or just from a site?
No. I mean, let's say you have a content block running.
Something.
Yeah.
Yeah. Really, we don't really need that much interaction with Leo's team because we understand how to add fields and add those components in. You know, sometimes we can go in and make a change if there's nothing particularly we need to bother the CMS team for, and we can just push it and it will just update, and it all happens at the build end.
Well, the interesting thing is it was also, in a kind of a weird way, it also taught the design team a little bit about Silverstripe specific objects. Yeah. Because
we've learned a lot about each other.
It's been great. But it is because, you know, like a link object, there's certain functions that use like an abs URL, stuff like that. That had to be replicated in the pattern library JSON. But once you've got that right once, and the design team see how that works, and they're clever people. They'll go, oh yeah, and they'll just reuse that. So that integration is fantastic. And yeah, anytime something changes, we rarely have, the CMS developer doesn't have to get involved. We're working on like back-end APIs now and stuff like that, you know, not necessarily the interactions with the front end. So yeah.
And you haven't had any issues with maintainability of code that way too? That
It's
things that you custom add as CMS developers that clash with like the front end things that are generated?
Not very often. I think that the main problem that we tend to have is sometimes we don't keep our JSON files in sync, and then something will break, but never on a live site. It will just break in the pattern library, and you'll kind of go to show a client something, you'll be like, okay, yeah, we'll send it over to you when we fix that thing, because the components appear in kind of a pattern list, and then they also appear in the page environment where we're showing examples. And sometimes someone might make a tweak somewhere in a JSON file, but forget to do it in the other place. That's kind of the only real issue that we tend to run into, isn't it?
Pretty much, yeah. Well, apart from the beginning of the project. But we've ironed those out now. And what's great about that is we can take that from each project to project and improve on it by having that consistent system that we can work from. You fix a bug in client A, and then you go to work in client B, that bug ain't there anymore.
Right.
So, but if you like pick up a module or something, you have to write update your parser so it like understands it, or so you always have the common denominator of both systems on possibilities?
Sort of. It kind of depends. So for some modules, like grid fields, for example, and stuff like that, we build that directly into the parser. And we do have to update those. But for other things, at the end of the day, the parser is really focused on the templates and the data model the template needs, and it can create content blocks and stuff like that. But you know, any modules you're using for any other customizations, like user forms. Oh, actually, no. A good example, like the news blocks, for example. You know, we'll create those templates using the parser, but the code that interacts with the user block is still handwritten code. But now the developers who are handwriting that code, you know, in the controller and so forth, have an IntelliSense view model object that they can integrate with for the templates. So they just have a whale of a time just going, oh, that's what I need. That's what I need, and they just input it in. So it really serves as that glue. So you still write custom CMS code. It's just you write more specific CMS code now. Not. It's really there to get rid of the boilerplate stuff.
Yeah, nice.
Mm-hmm. Do we have any more questions from the panel or from the audience?
All right, guys. Thank you very much.
Thank you.
Yeah.